Welcome to the next module. In this module, we will be studying about greenhouse gases and the climate change mechanism, especially in the Arctic. We will just go historically to understand how the climate change and its relation with carbon dioxide evolved. In 1824, Fourier first found out that the Earth was warmer than expected simply if we consider the solar radiation reaching the planet. So this is the starting point. Then Eunice Newton-Forte in 1856 was the first time she identified that carbon dioxide is actually responsible for this particular heat. So she demonstrated that warming effect of the sun is greater of the air with water vapor. So this is the second one, the second important greenhouse gas, that is the water vapor. So these two have more heating than the dry air, and the effect is even greater with carbon dioxide. So she first identified that carbon dioxide was responsible for the heating of our atmosphere. And then Tyndall in 1861 actually confirmed it. So he experimentally demonstrated that the gases such as carbon dioxide, methane, water vapor can effectively absorb infrared radiation, that is the greenhouse effect. So this is the initial beginning of understanding that these gases absorb infrared radiation. That is a very important identification he did. And then Arrhenius in 1896 quantitatively analyzed the impact of CO2 on Earth temperature. He developed a formula to predict how CO2 changes affect global temperature. So he has been considered as the person who predicted how the temperature will increase. And then Robert Wood in 1909, he challenged the existing greenhouse effect theories, and he showed that he also shifted the focus from carbon dioxide, methane to other gases. And Stewart Callender in 1938 made a very significant contribution, which is called the Callender effect. So he linked the CO2 level to industrialization and the global temperature increase. That is, CO2 increase is responsible through our anthropogenic activities, was first told by Callender. And he highlighted the implication of fossil fuel combustion for climate change. And then in 1958, the Keeling curve, what we are talking about, had done an excellent work, and he had shown the seasonal variation of carbon dioxide. So that is called the seesaw type curve, which is called the Keeling curve, and he showed graphically that rising CO2 levels in climate science. He was the first person to show that. He did the research in Hawaii. And then James Hansen in 1988 took a very important step, and he informed the policymaker to act significantly, raising public awareness. So these are all the historical facts about greenhouse gas and its relation with carbon dioxide, methane and water vapor. So the early observations started in the 19th century. The discovery of greenhouse gases was done by John Tyndall, and then linking of greenhouse gases and temperature carried out by Arrhenius, and even post-war scientific research had also connected the rising greenhouse gas levels with the observed temperature increase, especially in the polar region. Then people started understanding that, okay, there is heating happening. So the global climate model helped us understand how the changes are happening, and various scientific reports also mentioned that there is a rapid warming of Arctic. And then we started establishing the monitoring networks, like Arctic Climate Impact Assessment was carried out in 2004, which established to study and monitor changes, especially in the Arctic region, emphasizing the region's vulnerability to climate change. And then, of course, we know the Keeling curve, where Mauna Loa laboratory, he had carried out and observed the carbon dioxide's increase over a period of several decades, which was correlated to industrial activity. Then IPCC reports came in 2007. IPCC received the Nobel Prize for their important work on global climate change. So the IPCC reports, and then they also identified the sea ice decline due to increase in the temperature. Then recently, climate actions, many international agencies are involved in it, like a Paris Agreement, which is aiming to curb the greenhouse gas emissions and limit the global warming. This is recognizing the critical state of the Arctic. And of course, ongoing research include the impact of permafrost thawing, methane release, and its implication on global climate systems. So what is the calendar effect which we saw? Calendar showed that from 1880 to 1930, that is over a period of 50 years, that's what he had studied over 5 decades, that the global land temperature had increased. And he proposed that this increase could be explained as an effect of increase in CO2. So this is the only thing. So here he had slowly increased, the CO2 is increasing, so that's the reason the temperature is also increasing. In this y-axis he had shown that, and this is the time duration from 1890. He started that studies 1880, 1890, 1900, 1910, 1920, 1930, like over a period of 50 years he had carried out. And north temperature zone, tropical zone, south temperate zone, earth, and the average of earth annual temperature differences, all those things he measured. So he had shown that from 1920 onwards there is an increase in the temperature which can be correlated to increase in the carbon dioxide. But due to large variations, Arctic stations were not included in his particular study.